Hi everyone, I'm Tiki, and today we're going to be going over basic arc length for the SAT. Now, this is a pretty common topic I've seen in all the practice tests and even the SAT I took, with there being 1 to 2 problems on this on pretty much every one. It's a pretty simple concept, but it's hard to grab at first, so I'm going to go over the easiest way to understand this. So, if we look at the question asked here, we say, find the arc length of ABC. Now, one might not even know where to start with this when given a circle like this. So I first think, okay, where am I looking for? What length am I looking for? Because obviously it's not asking for the whole circle. It's always asking from A to B to C. So watch out with that because if they ask A, D, C, you could simply go the other way. So if they're asking A, B, C, make sure you're connecting A to B, then B to C, and that's the length they want. They want that whole thing. Now, I see this angle right here is asking for 120 out of 360. So I think, okay, it wants a fraction of this. It doesn't want the whole circumference. It only wants a little bit. So let's go over the circumference formula really quick. This will be given to you in your formula sheets on the SAT, but it's still good to know it off the top of your head just for timing reasons. So the circumference of a circle is equal to 2 pi r. R is the radius, or the distance from the center to the outside of the circle. Now we're given that right here, it says 4. So we're already given the radius, so we already know the circumference. Let's just plug it in. So if r equals 4, we get c equals 2 times pi times 4. Or 8 pi. Now the question becomes, what do we do with this number to get the 120 out of 360 degrees arc length? So all the question is asking is to take a fraction of the whole circumference. So we just have to take the fraction that 120 out of 360 is out of 8 pi. So let's just plug it in. 120 degrees out of 360 degrees times 8 pi centimeters. Don't forget your units. Now, this is something that I just kind of have to memorize, but I know that 12 times 3 is 36, and I know that 120 times 3 is 360. So I can just simplify this to 1/3. You do 1/3 times 8 pi centimeters. You already have your answer, which is 8/3 pi centimeters. Now, this one was obviously with a couple of easy numbers, and the next one will be a bit more challenging with the simplification of such a fraction. But this is just the basic way to do an arc length problem. It's just asking for a fraction of the whole circumference. So just to recap what we did the circumference formula, which is 2 pi r. We took the radius, which is 4 centimeters. We plugged it into our equation, and we got 8 pi. After using 8 pi, we had to take a fraction of that to get the arc length. So we were given 120 degrees for the angle, which means we only want 1/3 of the circumference, or 120 out of 360. We multiplied that by 8 pi to get the fraction of 8 pi, and we got 8/3 pi centimeters. That's the answer to this question, and that would be an answer choice that you could choose, or if this was a free response, that'd be one of the free response answers. Let's move on to a little bit more challenging problem that I want you to do yourself. So if you can, take a minute, pause the video, and I want you to find arc length A, B, C. Alright, let's get started. So notice how we were given the angle again, 135 degrees, and the radius again, which is 6 inches. So I always like to start by calculating the whole circumference. So let's do C equals 2 pi r. What's our r again? That's right, it's 6 inches. So we get C equals 12 pi. Now that we have C equals 12 pi, we have to take a fraction of that to get the arc length from A, B, C. Now, the piece of the circumference we're looking for is only 135 degrees out of 360. So that's all we got to do. We just got to multiply it. 135 out of 360 times 12 pi. Now this again is some simple multiplication you got to know for the SAT. So I know that 12 times 3 is 36. So I know that 12 times 30 would be 360. So I can take this out and put 30, and take this out and put 1. From here, I notice that this ends in 0 and this ends in 5. So my next best bet will be to divide by 5. 135 divided by 5 is 27. And 30 divided by 5 is 6. From there, I see that I can divide by 3, so I do 6 divided by 3, which is 2, and 27 divided by 3, which is 9. So we have 9 times pi over 2. This simply simplifies out to 9 pi halves. Now, this is usually not a problem, but just if you do this for any other math situation, remember your units. So we have 9 pi halves inches. That was basic arc length. Thank you for watching, and make sure to subscribe and like if you learned something new. I'll be delving more into geometric topics in the future as I find those the hardest on the SAT math section, so stay tuned for that.